Good morning. As part of our online learning for today, I'm going to ask you to watch a few short videos. And what I'm going to do is I'm going to work through a few of the problems from our quiz review, beginning with number 3 here. Graph the absolute value function and then use it to answer the questions. Well, I'm going to answer some of the questions right here from the equation, beginning with listing all transformations. They're easy enough to pull out of the equation. We start with a vertical stretch by a factor of 3. And then moving to the right, we see we're subtracting 1 here, which gives us an h value of positive 1, which means we're going to have a horizontal shift to the right by 1 unit. And then lastly, we're going to have a vertical shift down by 2 units. Next, we'll find the vertex. Again, as I noted, the h value is positive 1. Over here we see our k value is negative 3, and that's our vertex. 1, negative 2, I think I said 3. 1, negative 2, which gives us an axis of symmetry of x equals 1. X equals the h value. Now, I'm going to go ahead and graph a little dividing line. I'm going to graph the axis of symmetry as a dashed line. You do not have to do this on your graphs. I just find it helpful in visualizing and plotting the points so that I can graph my 2 lines. Next, I'll go ahead and plot my vertex at 1, negative 2. I'm giving you a nice big dot here so you can see it. You do not need a dot this big on your graph as long as you have the vertex in the right place. Now, I'm going to graph at least 1 point on each side. We could graph several points. We could go, I'm going to use the slope to do this. I'm not going to make a t-chart. I'm going to start at my vertex. Since my a value is 3, on the right-hand side of the axis of symmetry, the slope of my line is 3, which means I go up 3, and over 1. Now I could continue doing that, up 3 over 1, up 3 over 1. We really only need 2 points to define a line, though. If you're doing this freehand, it might be helpful to have a few lines or a few points to plot from. If you grab a straight edge off the counter in the back of the room, you can go ahead and just plot 2 points. And then sketch your line. And then we can mirror those points. We can either use the slope, realizing that the slope on the left-hand side of the axis of symmetry is the opposite. And I'll actually write the slope in here. The slope on this side is 3. The slope over here is going to be negative 3, the opposite. And I can either count off grid squares, 1, 2, 3 up, 1 over, or I can simply mirror points from the other side. There we go. And again, if you're using a straight edge, you really only need 2 points. And then we can go ahead and draw a line through them. And there's our absolute value function graphed. Now that we have it graphed, we can see a little more obviously the answers to the remaining questions. The domain is going to be all real numbers. And our range, we can see that it begins down here at a value of negative 2, and it goes up forever. So the end of that range is positive infinity. We never get there, so we get a parentheses on that side. Negative 2 is part of the function, so we use a square bracket. Interval of increase begins here and continues upward forever. The x value at the vertex where the increase begins is positive 1. Interval goes on forever. And again, at the value of 1, we're neither increasing nor decreasing. So we do not include that value in the interval. Interval decreases the other side. It begins at negative infinity. And we take the lowest value as the boundary, and it ends at 1. And there's our absolute value function.